A typical exothermic combustion reaction, such as the burning of methane, is represented by the following equation. And you're given the equation. Differentiate between exothermic reaction and endothermic reactions. And an exothermic reaction is a chemical reaction that releases energy, and an endothermic reaction is a chemical reaction that takes in energy. Sketch a fully labeled potential energy profile graph for this combustion reaction. Include the following labels on your graph: activation energy, delta H, potential energy of reactants, potential energy of products, and the potential energy of the activated complex. So you have delta H, which is between the potential energy of the reactants and the potential energy of the products. Your y-axis you label reaction coordinate. Your x-axis, on your y-axis potential energy, on your x-axis reaction coordinate, and your potential energy of the activated complex. So these two questions over here are level 1 questions. Lewis structures are diagrams that show bonding between atoms of a molecule and the lone pairs of electrons that may exist in a molecule. Draw a Lewis structure for each of the reactant and product molecules in the chemical equation above. So that's 4 different molecules that need to be drawn out. By this stage of your life, you should know that methane is a tetrahedral molecule. The carbon brings 4 electrons. They share 1 electron with each hydrogen, and the 4 hydrogens bond covalently. It's all nonmetals. Oxygen also, it is 2 nonmetals. They bond nonpolar covalently. Each oxygen brings 6 electrons. 2 pairs of electrons are shared between them. Carbon has 4 valence electrons. Each oxygen has got 6 valence electrons. 2 of them are shared with the carbon, and you're expected to know that carbon dioxide is a linear molecule. Water is an angular molecule with the 6 electrons from oxygen, 2 lone pairs at the top, and the shared electron with each of those hydrogens. Now you are expected to use those Lewis dot structures in conjunction with the table below to answer the questions that follow. The bond energy of 2 oxygen molecules is 2 times 298. Well, it's right there. 498, which is 996. The bond energy in 1 methane. Well, if you looked at that methane molecule, it's CHHH. And therefore you have got 4 carbon-hydrogen bonds, and that turns out to be 1,652 kilojoules per mole. You need to put the unit in. I've just run out of space on the page. Then when I look at a carbon dioxide molecule, it's C double bond O, double bond O. So C double bond O is 805. There are 2 of those that would need to be broken, so it's 2 times 805, and I'll end up with 1,610 kilojoules per mole. And finally, the bond energy in 2 water molecules, not just 1 now, so we are going to say 2 times, and if I look at it, it's oxygen, angle hydrogen, hydrogen, break, so it's 2 times oxygen, hydrogen, 464, and I land up with an answer of 1,856 kilojoules per mole. Use your answers above to prove that the delta H value is minus 818 kilojoules for this reaction. So delta H is the energy of the reactants minus the energy of the products. So it's 1652 because of the methane, plus the oxygen, 996, minus the products, 1610, and the energy of the other product, which is water. So altogether we are at negative 818 kilojoules. Got a short question on redox, and that question we get told that The laboratory is... So you get told this long story about heating and washing and chlorine being added. Then it's simple. It's again a level 1 question. Define the oxidizing agent. It is a substance that gains electrons and causes another substance to lose electrons. On the answer sheet provided, show the oxidation numbers of each of the following. So all we're going to do is put those oxidation numbers in, and it is -2 on the oxygens, -1 on the chlorines, +1 on the hydrogens, -1 on the chlorine, 0 on this chlorine because it's all by itself, -2 oxygen, +1 on hydrogen. Remember here it would be 2 times 1, so that becomes +2, -2, and that becomes 0. That was just a calculating number. Then over here I have got -2, so the manganese must be +2, and that's the end of my calculating numbers. Then my hydrogen chloride worked out beautifully. +1 -1 equals 0. -2 times 2, -4. Manganese +4, and that's the end of the calculation. Manganese +4. And then if I have to show the oxidation and the reduction, the chlorine goes from -1 to 0, so that is an oxidation. Manganese goes from +4 to +2, so that is a reduction.